Hello, everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 7C. I am Pranjal Banage, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development, ICT4SD 2026, in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday, 9 July 2026, in Goa, India, and the virtual event is being held through Zoom from 9 to 11 July 2026. I hope you'll enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for questions and answers. In 8 minutes, I'll raise a gentle reminder. There's another request to all of the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me or to my co host in the chat box. Now, before we start the session, I would like to introduce you all to the chair of this session, Dr. Himani Binjola. She is an associate professor at Graphic Era Hill University, Dehradun, Uttarakhand, India. She brings over 14 years of professional experience bridging mainstream media corporations and higher education. Her primary areas of interest include new media ecosystems, journalism ethics, public relations, media law, and development communication. Ma'am, I'd like to invite you to give a few opening remarks.
Thank you so much, Pranjal. That was really sweet of you. I've been associated with GR Foundation from a long time now. It's like I think every conference I myself I'm also participating, and they're also giving me chances. Being a chair of the session, it's a great opportunity, and I'm looking forward for all the papers. All the best to each participant, and I hope we'll have a great learning, and there will I'll be having a great time with all of you, and there will be a lot of points where I could also learn and I could also implement those things in my research papers and my research journey as well. So thank you so much, Pranjal. Looking forward for this session.
Thank you so much, ma'am, for your encouraging words. Now, we'll start the session with the first author. I'd like to invite Kuchimanchi Venkata Chachu Manisai to present his paper on AI-driven smart and integrated crop disease detection using remote sensing and deep learning for climate-resilient agriculture. You may start by presenting your screen. Mr. Venkat, are you there?
Good morning, ma'am.
Good morning. Sir, will you please share your screen and start with your presentation?
Good morning, ma'am. Myself, Mansai. Today, I'm going to discuss about my research paper, AI-driven smart and integrated crop disease detection using remote sensing and deep learning for climate-resilient agriculture. Coming to introduction, agriculture is the main backbone of our country, and it is a food security. But crop disease and pest causes significant yield loss worldwide. Traditional disease detection is manual, time-consuming, and often inaccurate, especially in some rural areas. AI remote sensing and deep learning enable early and accurate crop disease detection through automated monitoring. This was proposed as integrated NDVI analysis and CNN and cloud-based ICT framework for real-time crop disease detection. Methodology. First, we will take the data from satellite data acquisition, which is collected from MODI satellite and Sentinel-2 satellites, and NDVI analysis. Based on the satellite data, we will analyze the stress detection, and CNN-based disease classification is used to detect the disease on leaf images using plant village dataset. Cloud-based deployment. We have used AWS console to deploy the model onto the cloud version. The flowchart is the first we will take the satellite image, then Google Earth. We will analyze the image on the Google Earth engines, and we'll use the NDVA analysis where the crop is stressed or moderate or it is disease and leaf image collection, CNN disease classification. Coming to system architecture, satellite data collection from the Sentinel-2 and MODIS satellite images are stress detection. NDVA analysis identifies low vegetation stretched regions that require further inspection. CNN-based disease classification. Leaf images from stressed regions are pre-processed and classified using a CNN model trained on the plant village dataset. Cloud-based ICT platform. The trained model is deployed on the cloud, enabling farmers to upload leaf images and receive real-time disease predictions through a web application. This is a architecture diagram. First, we will take the data from the Sentinel-2 and MODIS satellite. Then the data is pre-processed from the Google Earth Engine, and we will analyze the NDVA analysis. The NDVA, for, if the it will be ranged from -1 to +1, and the leaf image will be collected. CNN-based disease classification, cloud-based deployment, farmer web application. Technology stack, here we have used Google Earth Engine for the satellite data analysis. For programming language, we have used Python, and for disease detection, we have used deep learning. And the trained dataset is the plant village dataset, which is downloaded from Kaggle, and Flask and web application for the user interface, and GitHub for code repository. Resultant analysis. We have got around accuracy of standalone is 91.8% and precision 91.2, recall 91.5, and F1 score we have got as a 91.3. For the NDVA based analysis, we have got accuracy as 88.6, precision as 87.9, recall as 88.2, F1 score as 88. And we have proposed a hybrid method such as 95, where we have got accuracy as 95.6, precision as a 94.8, recall as 95.2, F1 score as 95.2. The proposed hybrid approach achieved the highest performance with the 95.6 accuracy, outperforming both standard and CNN and NDVA based methods. Integrating NDVA and CNN improves disease detection reliability by combining large scale crops, stress monitoring with accurate leaf level disease detection. It is the output of what we have got. If it is green, it is a healthy crop. Where it is, if it is a yellow, it is moderate healthy, and if it is red, the crop should be analyzed, and we should go for the scanning, and we should take required precautions. For the CNN model, first we will upload the leaf image, and we will select the type of crop. Then we will check the disease prediction, which crop and what is the disease we have got, confidence score we will get. Throughout the discussion, the hybrid integration of NDVA and CNN improves disease detection accuracy by combining large-scale crop stress monitoring with leaf-level disease classification. The cloud-based ICT platform enables real-time, scalable, and remote access, making the system practical for farmers in rural areas. The system supports climate-resilient agriculture by enabling early disease detection and timely intervention, reducing potential crop losses. Current limitations include independence of NDVA under adverse weather conditions and the need of diverse high quality training data for improved model performance. Conclusion, future work. The proposed hybrid framework integrates remote sensing, NDVA, CNN, and cloud-based ICT to provide accurate and real-time crop disease detection. The system achieved 95.6 classification accuracy, enabling early disease identification and supporting climate resilient. Future work will integrate IoT sensors and drone-based monitoring to enhance data collection and improve real-time crop monitoring. Advanced AI models, larger data sets, and the decision support systems will be incorporated to improve prediction accuracy and provide treatment recommendations. These are the references where we have taken from. That's it, ma'am. Thank you. Hello.
Yes, sir, you're done.
Yes, ma'am.
I would like to ask our session chair if she has any questions. but it seems she has some network issues. It's fine. Thank you, Manisai, for such a wonderful presentation.
Thank you, ma'am.
Now we'll be moving forward. Then I'd like to invite the next author, Dugirala Kavya, to present her paper on an AI-driven framework for early detection of lung diseases using deep learning-based techniques. You may start with your presentation.
Okay. So is my screen visible?
Yes, your screen is visible.
Okay. So good morning, everyone. We are here to present our research paper on AI-driven framework for early detection of lung disease using deep learning. In that, so I'll talk about the modalities first. First of all, we have used two types of modalities, that is CT images and X-ray images. X-ray images for lung disease and CT for lung cancer detection. So, coming to the problem, the leading cause for death these days is we are detecting these things manually. The amount of time spent on reading the stuff, analyzing the papers, and also the images is taking far too time, which is causing delay in the medical procedures. So, the proposed solution is a way to reduce the gap between the time taken for the diagnosis and medical procedures. So we are aiming to do that. So coming to the proposed solution, the image input could be of two types, that is X-ray or CT, as I talked about, the two types of modalities. So after the input, we will be going it through adaptive pre-processing. That is, we will be denoising the images and all the other features that we will be doing on that image augmentation and all the stuff on that. And later comes the feature extraction, which is done using efficient net model. We'll be doing feature extraction, and later we have training, that is warm up and fine tuning. And the later output would be the prediction score, disease, and also we get a confidence score based on that. So coming to the images that we used, we had the X-ray images of four types, that is COVID-19, pneumonia, TB, and normal images, which were approximately 1400 images. So these were the images that were used to train the model. And coming to the CT scan images, we used around uh, 2000 images, which were of three types. One was malignant, benign, and normal images. So these were the image types that we used. And coming to the methodology, so what we did was data collection as usual. And coming to the noise removal and pre-processing, we have used different methods like bilateral filtering, salt and pepper, median filter, Gaussian filter, and all those things. And also edge shaping, resizing the image to the certain value, and grayscaling, converting the grayscale to RGB, and all those things. And coming to the image augmentation, we use different methods like flip, rotate, brightness improving, and zooming applied on each epoch, and all those stuff to come up with better images for the prediction. So coming to the efficient architecture, we used high accuracy, fewer parameters pre-trained on the backbone, as we know that efficient net is usually used for medical images. And then coming to the two-stage training, we used two stage training, that is warm up and fine tuning. So that's all with the methodology. And this is the features that we used in the medical format, mathematical format. And the accuracy results were around 95 across all the classes. These were the results. So, yeah, and coming to the deployment, we deployed it in the Hugging Face for the purpose. Yeah, that's all.
Thank you so much, Kavya, for that insightful and engaging presentation. Now we'd like to move
Thank you.
forward with our next author, Jayasri Sangarchu. I'd like to invite you to present your paper on crop stress detection using ML. You may start your presentation.
Pranjal, can you see me?
Yes, ma'am, you're visible. You were
I'm so
disconnected for
sorry.
a while.
Actually, there is heavy rainfall happening in Dehradun, so internet is this is a technical glitch is happening online. So I just joined from a mobile phone. Is it
Yes, ma'am.
Pranjal is
Ma'am, are you
Venkat?
there?
Yes, yes, yes. I'm there. Is Pranjal done with his presentation? Sorry, Pranjal is Venkat is done with his presentation, I think.
Yes, ma'am, he's done with his presentation.
So I should ask him a few questions so that or we should go on the next one.
If you'd like to ask a few questions, you can.
Yes, one or two questions I had. Mr. Venkat, the research is really nice, and the way you have used the new technologies that you have used research for, like, how can you use this research for educating farmers or on real ground? How will you implement this research?
Ma'am, sorry, please, can you repeat the question once again, ma'am?
I'm saying, Mr. Venkat, it is a really interesting topic that you have taken, and the way you have crafted your entire paper. I'm saying that on ground, how will you use your research, the outcome that has come for helping the real time farmers, or on ground, how will you help? How will be using your research?
Hello, hello, ma'am. Am I audible, ma'am? Hello.
Yes, sir, you're audible.
The main goal of my research is to make a disease detection for practical for farmers. On the
Hmm.
ground of farmers, they can use the mobile application and they can upload the image through through mobile application or web application. They can upload a crop leaf image. Our model will analyze the crop leaf image detection, disease detection, while satellite-based remote sensing helps the monitor to crop based on the NDV analysis, where the it is based on the crop disease sand moisturizer. The system that provides early warnings and suggests appropriate treatment for the farmers, which treatment they need to take. This helps farmers detect disease early, reduce crop losses, and lower pesticide usage and improve overall yield. In the future, we can also this solution can be deployed through agriculture departments, farmer producer organization, or extensions centers, so that even small farmers can easily get benefits through our project, ma'am. That's it.
Oh. Have you done any means just by any chance have you done any pilot study?
Yes, ma'am.
I think you will be probably doing it now.
Ma'am, sorry, your voice is getting stuck, ma'am.
Okay. I am saying that by any chance, have you done any pilot study or you will be doing it? Do you have that in plan?
Ma'am, we have taken references and we have proceeded with the project, ma'am. It is our capstone project in our final year BTech, ma'am. And
Oh, nice. Okay. Okay.
we have worked on that, ma'am.
Much all the best for your future endeavors. Thank you.
Thank you, ma'am.
Thank you so much, ma'am, for your inputs.
Thank you, Ranjan.
Now, I'd like to invite Sangaraju Jayasri to present her paper. Jayasri, just to let you know, if you're speaking, you're not audible. Miss Jayasri? I think she has some technical difficulties. Then we'll be moving forward. Jayasri will be taking your presentation in the end when you have resolved all your issues. Now then, I'd like to move forward and call our next author, which is Prem Ghute, to present his paper on Cyber Suraksha app. You may start with your presentation. It seems that Prem Ghute is not present. Then once again, we'll be moving forward and I'll be calling the next author, Viranchi Pandya, to present his paper on design and implementation of 16-bit RISC processor. Sir, you may start with your presentation. Mr. Viranchi Pandya? I'm sorry, but I'd like to ask, am I audible?
Yes, Pranjal, you're audible.
Yes, Pranjal, you're audible.
Thank you.
Okay. So is my screen visible?
Yes, sir, your screen is visible.
So now let me start with the presentation for design and implementation of 16-bit RISC processor. Now, the RISC stands for Reduced Instruction Set Computing, and the presentation introduction, literature review, proposed architecture discussion, conclusion, and references. Now, to design a RISC-based application-specific or specifically designed architecture for applications that we want to go forward in some future. So the RISC stands for RISC. It is a fixed length instruction set where instruction decoding and improved execution speed can be done. It is with Harvard architecture where data memory and code memory are separated so that memory conflict will be reduced. Then it's also having a pipeline architecture for concurrent execution of multiple instructions at the same time. Now, in this particular design, we proposed a 5-set pipeline architecture, which is designed. Various literature review where we have seen that many of the persons have designed the RISC with multiple cycle data path for the hazards utilization. Certain have 16-bit pipeline MIPS RISC architecture with Harvard architecture. Certain have designed with ALU with propagation delay reduction. Then this part. So here in this case, in our proposed architecture, we have designed with Harvard architecture, which supports 16-bit fixed length instructions. That means each instruction is having 16-bit support. Data line is of 16-bit. It is having a 5-stage pipeline architecture. It includes program counter, various register files. Specifically, in this particular design, we have proposed different registers for the. We have designed ALU, arithmetic and logic unit, with carry loop ahead adder for the fast arithmetic logic support, control unit design, and various memories for instruction set as well as data. It supports mainly arithmetic, logic, memory, and control instructions. With the pipeline architecture, the first pipeline is of instruction fetch. So it will get the data from the instruction memory. From the memory, it will go to the fetching cycle. The second will be instruction decoder, which will decode the instruction and it will identify the meaning of the instruction. And based on the instruction meaning, it will generate certain control signals like memory read, memory write, input output read, or input output write. Various types of signals will be generated. It may be register read, register write, push. Then the third pipeline stage is the execution. So it will activated and particular branch or particular ALU will be activated with various register banks and the result will be generated. Now, once the result will be generated, the next will be activated, that is memory access. So ALU will produce the result. Nothing on the instruction. It will either return to the memory or it will be stored back from the memory to the register bank. Now write back certain instructions. We have to write back to the registers like add, subtract. So whatever result is ready, it is to be written back to the register again. Now the main benefit of the pipeline structure is to improve the throughput by parallelly 5 different instructions are to be executed at the same time. For example, if the first instruction is in IF, now whenever the instruction is moving from IF to ID, the second instruction will be available with IF. Now the first instruction is moving from ID to execute, the second will move to ID and third will enter to the IF. But the first instruction is moving towards MEM, the next second instruction will be at EX, third will be at ID, and fourth will be at IF. And whenever the first instruction is at WB, write back, ultimately the fifth instruction will be entered into the fetch. So if the size of the instructions are same, then parallelly 5 different instructions are to be executed simultaneously. And that is the main benefit of RISC architecture, where maximum 95% of the instructions are of same size and almost one instruction will be completed in one clock cycle. Now, if you see the proposed architecture, it will be looking like this. Initially, from the program counter, the first part will be available at the instruction memory. Now, from the particular memory, particular code will be transferred to the fetch phase. Now, in the fetch phase, instruction will be identified and then it will move forward to the decoder. Now, whenever decoder will identify the meaning of the instruction, it will generate the control signal. Now, whenever control signal is activated, it will be selecting a particular register or a particular slot of memory, and then it will move forward towards the multiplexer side. And whenever it will go to the execution phase, multiplexer will select a particular control signal so that particular register can be entered into the ALU, and second register will be entered into the ALU, and ALU will produce the result. Once the result is ready, either it will be stored inside the memory or it will be written back. That is, WB stands for return back to the original register, and for that forwarding unit will be activated and result will be stored back into the register bank. Now, in this particular case, various types of instruction set we have generated with hardware. So there are 5 types of instruction set we have generated. R, that is register type instruction, where mainly arithmetic and logical operations. I stands for immediate operations to be generated. Then L store, LD, load store type of instruction will access the data from the memory. Next is the branch instruction. So it will support the conditional branch, for example, jump on query, jump on zero, something like this. Depending on particular condition, the branch will be activated. Then jump, there is certain instructions like without any condition, if you want to jump or it will modify the control flow, then this particular slot will be activated. Now fixed, all the instructions are fixed with 16-bit instruction format so that pipelining can be activated at the same time. Now, whenever particular instruction is activated, it is having opcode or a particular code. So each instruction operation, function operation, then bit register bank 2 to bit 1 or source register 1, then bit number 9 to bit number 11 will provide the address of the destination register or RD, and bit number 12 to bit number 15 will be for opcode for a particular type of the instruction. For example, if it is register type, then 00 something. If it is immediate type, then 10 something. Load stop type, then 11. So that is the opcode type of particular instruction. It will be more clear once we see the execution phase. Now, in this particular design, we have generated total 16 number of instructions. So various R type instructions are add, subtract, and, or, XOR, shift left, and shift right. I type of instructions are logical and immediate, logical or immediate, logical add immediate. Load and store type of instructions are something like if you want to transfer the data from the memory to the register, then load. And if you want to transfer the data from the register to the memory, then it will be stored. If you want to go with the branch instruction, then if both the register contents are equal, and if you want to branch or if you want to jump, then BEQ, and if not equal, then BNE. And without any condition, if you want to jump, then JMP. So it is to be implemented, it is already implemented on a Xilinx software, and we have found out the result for the same. Presently, if you see the structure of the result, initially it is a clock version, that is the clock for the processor. In this case, it is 50 megahertz clock. Then if you see the highlighted version, it is the opcode of a particular instruction. Now, if you see 0010, then 0010 is the opcode for the add instruction. After 0010, it is written 011. So 011 is the code for the destination register, that is R3. 011 is 3. Then it is 010, it is the source register 1. So it is R2. 010 is 2. Then it is 101. So 101 stands for R5. That means source register 2. So it is R5. And then opcode operation 000. So it can be used for the future, but presently it is with reference to no use. So this opcode will identify that it is the add operation where the destination is R3 and two source registers are R2 and R5. Now, before this instruction, we have loaded the content 02 into the R2 and 05 into the R5. So after this execution phase, if you see the last row, this pipeline is executed in the right back. 07 is to be transferred into the right back register, and that will be R3 content will be 07. So 07, after this, the result will be transferred to a particular register, that is the destination register, which is already mentioned in the opcode. Now the same is applicable for subtract instruction. So subtract instruction, the code will be different. 0011. Again, there are two source register R5, R1, and the destination register is R6. So 101 and R5 minus R1, so 0005 will be stored inside R6. Now there are similar type of execution is available for all the instructions that we have designed. We have designed total 16 number of instructions. This is the synthesis result of the Xilinx Vivado, and these are the 5 pipeline stages which is to be available, which is similar to the our earlier proposed architecture is available like this. The same is Vivado, and it will be looking like this. ALU is designed, memory is designed, opcode instruction set, all this designed within the memory, and the operation is performed on this particular hardware. Result is ready, and result is already discussed. So ultimately, what we have done, we have designed and implemented a 16-bit RISC processor using a stage pipeline hardware architecture. We have developed the processor including program counter, register file, arithmetic and logic unit, instruction memory, data memory using Verilog, HDL, VHDL. ALU is available with carry look ahead header for improving the performance. For this case, we have achieved the efficient hardware utilization with 309 slice lookup table and 365 registers with a power consumption for this particular hardware is 1.041 watts. These are the certain references. Now, if you have any questions, thank you for your part. Okay, if
Thank
you have
you
any
so much.
questions.
Ma'am, do you have any questions for him?
Dr. Viranchi, it was really interesting.
Madam, I cannot hear you. Your voice is. Hello.
Dr. Viranchi, am I audible now?
Yes, yes, yes.
I'm saying that Dr. Viranchi, it was you have explained your topic so nicely, so deeply, and it was all appreciation for your presentation. I just wanted to know that what was the idea behind your research, what you were thinking when you were selecting of this topic, when you were working on this. So because I could see that there are 3, 4 co-authors also, so it must be a teamwork.
Yes,
So
yes.
what was all?
Yes. Basically, yes. Basically, it is the MTech. One of the student MTech Dhaval is also there in with the presentation, Mr. Dhaval Badaria, and he has done one of the project with his MTech subject where computer architecture is the main idea. So in this case, presently we are having various types of embedded systems in the market. Now, every time we do not have to design the processor, which is very bulky. I mean, number of instructions are more, number of pipelines are more. So, if we want application-specific device, for example, smaller applications, we need smaller processor, right? For example, a wearable device in our watch, very small device is needed, and for that we do not going to go. Instructions are needed. Very limited architecture is needed, and that is why this type of projects are developed, which can be given to the company so that particular application it will be work for a particular part, and smaller device can work on this particular architecture. That is why it was designed.
Okay, thank you, Dr. Viranchi. All the very best for your future endeavors. Thank you.
Thank you, madam.
Thank you.
Thank you.
Thank you so much, sir, for that incredible presentation. Next, I'd like to call upon Lokesh Samrit to present his paper on design of an integrated iterative RAG-based multi-model contextual intelligence model for real-time disaster response analytics. You may start by presenting your screen.
Good morning, everyone. Hope my screen is visible, ma'am.
Yes, sir, your screen is visible.
Yeah, thank you so much for confirming. So, good morning, everyone. My name is Lokesh Samrit, and I'm working as a senior technical architect in Hexaver Technologies, and I'm here to present a topic, my research topic on iterative ICMF, which stands for Iterative Contextual Multimodal Fusion for Adaptive Disaster Intelligence. So before I introduce this, so let me give a real time example. So for example, currently we are facing the same situation, right? Uh, there is a flood everywhere, right? So imagine we are sleeping at night and suddenly the flood came. So what we will do? We will call up the emergency response team, right? They are busy, so we'll send a text, we'll send a social media messages, a lot of things, right? So the imagine the situation of the person sitting at the emergency response team, right? So he is flooded with a lot of information, a lot of data, a lot of sensor data, a lot of text messages, everything. Now it is difficult for that person to make a one concrete decision where to deploy the response team, right? So that is the problem, and that is where ICMF stands. So ICMF works on a basic principle: multiple data source, but one clear vision to save people life, one clear decision to save the who are stuck in the disaster. So to to give more understanding on the problem, I just want to go to the core of the problem. So there are a number of researchers in this area, but they work on a single model. For example, there are researchers which works on either aerial data, the aerial images from the satellite, or the social media post, or some calculation to show the the disaster. But the real problem for this is it's not a lack of data. It's the problem is the integrated data, and to retrieve the data, to clear it out and make one proper solution. So that is the problem, and that is where ICM comes. Now these are the research gaps or literature review, I would say, where they are singular modular, just like I said. Their work on either a social media post, or the aerial images, or some calculation to predict the disaster. But these doesn't collectively works to produce one complete decision, right? So that is where ICMF come into the picture. So now what is ICMF? So ICMF is iterative contextual multimodal fusion. So what does it mean is it actually takes the data from multiple sources. I'm sorry. It takes the data from multiple sources, retrieve the data, correct that data, and based on that, it fuse that data, complete data. It doesn't work on a single model. It works on a complete data, and then based on that, it makes one complete decision, and it gives the data to the person who is sitting in the emergency response team, so that he can make a decision and send the emergency response team. So how does it work? So basically, like I said, right, in the disaster like situation, the images or the text data which come in a distorted format, right? So, and it comes from multiple sources. So what ICMF does is it takes the data from all of these sources, it retrieves the data, it cleans the data, corrects the data, right? And then it 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 calculates, it fuses that data into one, and based on all this data analysis, it come up with one solution that this area is flooded, though this is high risk area, and we need to send an emergency response team to this area, right? So this is what I have. And then the flowchart, like I said, it works on multiple inputs. it it gets that, it retrieves the data, it calculates, it measures that contextual drift, and it then fuses all that data and make one decision for a person sitting in an operating room. Now the implementation part of it. So I have used a MVC architecture here, like model view and controller, where the front end I have developed in a React, which is our view, and then the model, once the data comes from a front end, the model which is developed in a Spring Boot, which takes the data, modelizes the data, and send it to the controller there, which is a Python intelligence API, which takes that data, calculates that data, cleans that data, fuse that data together, and make a decision whether it's a high risk zone or a low risk zone or a medium risk zone, and deploy the emergency response team based on the decision. So this is the implementation, and this is the result. So the person sitting in the operator room, he will get the data, he will feed that data into the ICMF portal, like it's a text, right? The if he receives the text, he will input it text. If he has received the images, the satellite images, he will add that. If he receives the sensor, like the humidity or the pressure, or the sensor data, he'll feed that out, and at the same time he'll add some of the things. For example, I got a call a few minutes back, so that call and that data he will add it to the previous context, and based on that, ISMF is smart enough to understand the data and calculate a risk. Based on all this, it will read the image, it will read that text, sensor values, and based on that, it will calculate a drip score, and it will say like whether it's a high risk zone, or it's a low risk zone, or it's a medium risk zone, and based on that, it will dispatch the team. So tools and technologies, like I said, Spring Boot and React and um, Python I have used. And conclusion, to conclude, so disasters are like a tragedy no one like to face, and this is uh, the this ICMF address the problems which are present in the current system, which are single modular, and they just work on a single model to give a decision, but that is not enough for a person sitting in a emergency response team to send a help to the one which are needed, right? That is where ICMF stands, and it reads data from multiple sources, fuse it together, and give one solution. So this is what I have. These are the references I have taken, and that's it. I have.
Thank you so much for such an intellectual presentation. Ma'am, do you have any questions for him?
Mr. Lokesh, it is a very nice topic, and the way you have researched on ground, and especially from a place I come from, Uttarakhand, this research is absolutely applicable for us because, unfortunately, our mountains are new folded mountains, and there has been casualty like Dharali and Tharali, and so it is very much applicable.
Exactly.
So, kudos to you and your guide who has that you have worked under her supervision. Mr. Lokesh, was there any theoretical framework or any model that was going in your mind when you were preparing this research topic? And it is very much applicable on ground. Like, I think you
Correct.
should really carry forward this work, and states like us, like especially Uttarakhand, Himachal, will be more than benefited because we really don't know when casualty will come at our places. So I just want to know a little about that.
Yeah, ma'am. So basically, I mean, like you said, like the Uttarakhand and Himachal. So we have seen a lot of tragedies like this, like in the Kedarnath, right? Similarly, in 2021, there was the flood in Maharashtra, where the place Pandharpur, right? It was flooded like anything. All of the animals, or the humans, they were stuck in the flood, like they were not getting the emergency response. 2 3 days they were sitting on the top of their houses waiting for the response, but they are not getting the proper response, right? So that is what it came into my mind, like we should research in that area, like I mean, the country like India, where we have a lot of people, like 140 billion people, right? And emergency response team is very limited, right? So we have to accurately deploy that team so that the person in need should get that help. So that is where that is what it came into my mind, and I thought of researching to that area.
Okay. Okay, Mr. Lukesh, all the very best, and thank you so much for this interesting presentation. And I hope you carry forward this in the right direction, and the policymakers really get benefited with your research.
Sure, ma'am. Sure. Thank you so much for your valuable feedback, ma'am. Thank you.
Thank you. Thanks so much, Lukesh.
Moving forward, I'd like to invite our next author, Kaustubh Sonde, to present his paper on Higher Guard, Authentic Recruitment Validation. You may start your presentation.
Hi, good morning, Pranjal. Hope I'm audible to you.
Good morning.
And I hope my
You are
screen is
audible,
visible
sir.
as well.
Yeah, your screen is visible as well.
All right, I'll just quickly get started. Present this. Yeah, there it is. All right, so I researched on HireGuard, and the problem over here that we were trying to solve is that whenever me or anyone from my class or anyone, anyone in my friend group who were trying to apply for jobs, we used to always run into these scammers which used to ask for some sort of an enrollment fee, some sort of a payment, or anything, any misleading thing that you come meet up with me, we'll take your interview over here, blah blah blah. These sort of Indian nuisances that we used to experience. So to battle this, we just researched on HireGuard. And yes, the core technology that we had used in this was a hybrid classifier and a rule-based layer to detect a linguistic patterns over here as well. So I'll just quickly tell you the key objectives that we are trying to solve. Uh, we had a lot of class imbalances in Indian market nuances, as I told you, and we were limited to information from web scrapers, English only processing, and it was very vulnerable for job seekers to fight against these deceptive digital threats. So we just came up with a consultancy platform delivering personalized, real-time industry advice with feasible scoring, trend analysis, and tailored roadmap. Basically, a whole guide for you, making it affordable, accessible, and actionable to each and every student. And moving on to literature, we had actually quite a lot of trouble finding good data set for this project because one of the problems in machine learning is finding a high quality data set. And we luckily found this one data set, the MSCAT data set, but this also had a severe class imbalance. Right, this class imbalance was 19:1, where the accuracy paradox fails to measure the effectiveness. And then this data set that we used, it was trained on other postings as well. We took postings from Reddit, we took postings from LinkedIn. All of these postings were web scraped and further added on to the data set as a part of our contribution to it. I'll just walk you guys through the methodology that we were using. First of all, we are using data extraction to gather information, right? So when the user gets prompted, you can enter URL, you can enter a screenshot of the job posting that you are planning to apply for, and then the data will be automatically skipped from that screenshot from that URL that which you have put in, and all of this data will be fed to our system. Now, over here in our system, we have also done some sort of feature engineering where we're only taking some of the information that you have provided and then cross-verifying it with the data set that we have, seeing if those patterns match, then making a score for you, see if this job is actually suitable for you, and recommending a risk score for it, and then you can decide whether you should apply or not. So we have some regex patterns that we commonly come across, which ask for WhatsApp contact request and easy money and unrealistic salary claims. So all of these we had adjusted in our fraud probability as well. And then these results that we got, currently we have benchmarked it to around 80%. And the reason we could not go above 80% was that we did not have a huge amount of high quality data. Further moving ahead, so when we implemented this, we took about 17,000 label job listings, which included OCR and URLs and screenshots. And beyond prediction, HireGuard had provided a value through red flag detection as well, identifying common scams indicators such as fee requests, advance payments, free email domains, WhatsApp only communication. So Overall, this became an explicable AI reasoning engine highlighting the most influential features behind its prediction, increasing the transparency between the user and the platform, building trust. The technologies we used over here were Python, Fast API, Skylit, Beautiful Soup, Tesseract, just to name a few. And overall, this had to be bootstrapped for a responsive web design so that everyone could access it from anywhere. To conclude my session, we made a multimodal analysis model which combines 13 plus features, which gives you a trust Celtic score, which helps you decide whether a job could be fake or it could be real. We do have some future scopes as well, considering the fact that we get access to resources, a large data set, and a lot of computing power. We can take this to new heights that no one has ever seen. Thank you so much. This is how the platform looks like. You can upload a URL, you can upload manually as well, you can upload a screenshot to this as well. And then you just get the complete information. You get all of the red flag summaries. You also get a risk analysis code over here as well. So over here, I think you can see that this job is a risk analysis of 20%. It seems like it is a safe job over here, so you should apply to it. And that's all from my end, Pranjal.
Thank you so much, Kaustubh, for such an engaging and knowledgeable presentation. I'd like to ask our session chair, ma'am, do you have any questions for him?
Thank you, Pranjal. Kaustubh, it was a great research paper that you're working on with your fellow co-authors. I would like to know that was there any theoretical framework that you were following for this research paper, or any model that you were considering, any theoretical model or framework that you were considering while writing this paper or doing this research paper?
Actually, yes, we were considering using a bidirectional transformer BERT, but once we actually looked into it, that had its own drawbacks. So as I said, we did not have a lot of data to it, and to actually use that bidirectional transformer, we needed to feed a lot of data. So we went ahead with a more traditional machine learning model, and on top of that machine learning model, we also added rule-based layers to it to just make it more accurate and to just sort of narrow down the niche to what we're looking for.
Okay. So, Kaustubh, I think the less amount of data set was your biggest limitation to this research, right?
Yes, ma'am.
And how do you see in the future, what future scope do you see for your research? Like what could be done by the future researchers if they work in this direction?
For future researchers, I would suggest just gather a lot of data, because that is a huge problem that even as I mentioned, one of the biggest problems in modern machine learning is the unavailability of high quality training data that we have. And another thing is that you should look into other research papers as well, because when we looked into other research papers, that's when we found out about the MSCAT data set. That's when we found out about how the class imbalances are. So the other research papers also helped us quite a lot.
Okay. Okay, Kaustubh, all the very best. And thank you so much for your presentation. Okay.
Thank you. Now we'll be moving forward. I'd like to invite our next author, Soham Maniar, to present his paper on Recruitment Enhancer, an AI-powered resume validator and candidate background verifier. You may start with your presentation.
Hello, am I audible?
Yes, sir, you're audible.
Yeah. Okay, so is my screen visible?
Yes, Soham, your screen is visible.
Okay. So good morning, ma'am. Good morning, Pranjal. My name is Soham Pankaj Minyar, and me here with my fellow co-authors and colleagues, we are presenting our paper, AI-powered resume validator and candidate background verifier. So this topic was our final year project topic for BE project, and it was sponsored by a company named the Equations Work IT Services. Uh, I will start with the problem which the industry faces. So today, like when there is a recruitment drive or a recruitment session, like the HR team or the any of the office or the company get thousands of resume, and the HR team get flooded with those resume. And to analyze the resume, get the information of the candidate, analyze their background takes huge amount of time. And due to this, the team can lose the effective and potential candidates, due to which the best eligible candidates don't get the most potential job as per their potential. So to in order to tackle this issue, we present this solution. So as I mentioned, there are thousands of resume for a single job application, and analyzing each and every application for every person is very difficult. Also, uh, like some of the candidates can fake their resume. Like someone can mention that the person has done an internship or a project with any of the MNC like Google or Amazon. But how can we verify if he or she has really done any large scale projects? So HR teams cannot manually do all the stuff for thousands and hundreds of resume. Also, to efficiently maximize the speed of resume scanning and validation, the system was proposed. So motivation was basically to avoid the resume inflation and to get the best hire candidates for a company or an industry. Then to minimize the cost of bad hires, because if a team takes a lot of time to analyze just the resumes and to shortlist them, it is not a good thing for any of the company. Then there can be human biasness, because sometimes we get irritated because of these large numbers, or sometimes the human tendency is that, okay, I have analyzed hundreds of resume, so I won't going further with more numbers, and due to this there can be inefficiency. So in order to avoid all this and tackle this issue, the problem was the solution was given. So the goal of the project was to make a system where the HR team will just upload the resume and get the final shortlisting of the candidate based on the threshold values, the constraints, the input given by the team. Um, so uh, this was the literature survey done by us. So we did analyze around 25 to 30 research papers, and we did found out that the main issue is that there is no such end-to-end system where we could get where the team will just upload the resumes and the job description, and the finally will get a summary of the report. So this was a literature survey. So I will just tell first the architecture diagram. So the end-to-end flow is that the HR team will upload the resume as well as the job description on the dashboard. Uh, Here it is given. Then our system would analyze the resume as well as the job description, convert it into embeddings, then scrape the vital information such as the college, institute from which the candidate has graduated, then his or her LinkedIn profile, GitHub profile, and along with that any social profile is present. Then the system will go and check the LinkedIn profile for the information like if the candidate had genuinely passed or graduated from the institute mentioned in the mentioned on the resume, as well as from the GitHub we could scrape the information like the projects or the projects that he or she has completed in his past experiences or as a learning projects, and then we could get a final report. Uh, and then the report will include all the stuffs like what was the candidate score, why should we hire a candidate, why shouldn't we hire a candidate, and all those stuffs. So yeah, so comparison with existing system. Um, so the current system just does the linear or sequential model search, but our system does the AI agentic search. So what is that? So basically, any like the current system only does everything in a sequential order. It n- doesn't check any of the things like should we really do any of the process or not. But our system does it. Then parsing. For parsing, the industry follows just the keyword based parsing, but we are using semantic search in order to extract more information. Like the resume mentioned React.js, but the job description mentioned React. So both are the same things. So we use the semantic searching. Then code validation. We have implemented the GitHub verification and validation system, where the system would check the code quality of the candidate, which is pushed onto the his profile or the repository. So we could analyze the what was the code quality, how when was the code pushed, then any of the red flags like um, uh, it is AI generated code or copied from any of the other projects, cloning and all those stuff. Then matching algorithm. The system follow global embedding, but we follow sectional embedding because we could get more information from the particular sections rather than just analyzing the whole resume. And then finally, the interview system. So currently the interview are processed manually, human to human, but our system introduces a RAG-based interview co-pilot where the questions will be generated based on the candidate's resume as well as the job description given by the HR team. So I will not tell the whole flow. The HR team will upload the resume. Then as well as they will upload the job description. Then our system will scrape all those things from the job description as well as the resume. Then it will be stored into the database. Then there is an agentic AI brain system which would check whether to scrape what information and what not. Also, there is a deduplication logic to check if we should scrape the resume information from scratch. Like if the same resume was scraped yesterday and we need to scrape it today also, then it is not a good thing because we are wasting our resources. So we did put an deduplication logic such that if the resume was entered into a system less than 7 days, then only the GitHub will be scraped. If between 7 to 14 days, then it will be LinkedIn and GitHub both will be scraped. And if the resume is still more than 30 days, then all the system will be reported again, and the final report will be generated. Uh, so these were the algorithms used in our system. First one was the fuzzy matching algorithm. The fuzzy matching algorithm was basically to check for the GitHub repository name given into the resume as well as the GitHub repository name present on the repository. For example, like if anyone has done a project like e-commerce platform, but the name can be different, like an e-commerce platform, only e-commerce platform, or like e-commerce. So for that matching, the fuzzy logic was used. Then cosine similarity. Cosine similarity was basically used for converting into the embeddings and then searching for the particular information and extract that information from the embeddings. Then dynamic weight redistribution. So we were assigning the weights for each of the extracted fields, like the LinkedIn score, GitHub score, or any other score which we would get. Then we would normalize those weights and give the aggregated results. And last one was the weighted skill scoring algorithm. So the scores were normalized between range of 0 to 1 because there might happen that some of the scores get high marks. Like for example, if the LinkedIn is getting 80 out of 100, but GitHub is only getting 40. So in the aggregate would not give a clear idea of what should be the final score. So we were normalizing that score. Then these were just the basic software and hardware requirements that the front end was built in React and Tailwind CSS. Backend was based on the Python and Fast API framework. Database was MongoDB and PostgreSQL. Then we did use the ML models for the conversion of text into the embedding. That is the all mini LM L6 and BG large. And the CodeBot was used for the similarity search. Then there were the use of LLMs via the use of API key. So we did use the Gemini API key and the Grok as the fallback API. And then for web automation, Playwright Selenium was used and orchestration LangChain was used. Then these are the images of the project which were developed. So this is the landing page where we could get the information about the job posting and all those stuffs which the HR should know. Like here we can see how many total jobs are there, how many active jobs are there, average math score, UI UX designer, and all those stuff. Then the first one will be the posting part where the HR team can post a new job. Like he or she will create a new job button. Then they will post the information like what is the title of the job, then what will be the job description, what will be the core skills required for this job, and all those things. As well as they can also mention about the location, salary range, and how will be the type of interview, like it will be online, offline, hybrid mode, etc. Then once the job is posted, the HR system can upload the resumes. They can upload a single resume to hundreds to thousands of resume, and once they upload the resume, our system will start. So once the system starts, it will extract the information for each resume in about 85 to 90 seconds. And after those 90 seconds, the final report will be generated. And this is an example of the report. Like the name of the, here we can see the name of the candidate, then the role match score. Role match score means the if the role was for a full stack developer, and if the candidate has all the things like full stack, front end, back end, then how relevant is the candidate for that particular job role. Then second one is the experience depth. Experience depth means the how much the candidate is experienced in that particular domain, like what projects was done, what were the quality of the projects, where they were deployed, what were the stack used for this project, etc. And then finally, the verification. Verification is the GitHub verification, where we could see the code quality, the number of projects made for that particular domain, then how was the project made, where what all things were included, and all those stuffs.
So
Then
sorry to interrupt, Soham,
Yeah,
but your time is up. I'd request you to conclude your presentation.
yeah, sure. So these are the further like GUIs only, and the result analysis. The main thing is the result analysis. So manually doing any of the for a single candidate, manually analyzing the resume would take around 8 to 10 minutes, and it can go up to 15 minutes if the resume is too large or too complicated. But our system reduces the time to only 85 to 90 seconds, which is a huge reduction in time. So around we are getting 90% time reduction. Then second is the asynchronous processing speed. So so that the we are processing it asynchronously, so that thousands of resume can be processed asynchronously. There is no waiting time like one after the other resume. Then this is the full end-to-end pipeline, so that the HR team can get the final shortlisting rather than analyzing it one by one, step by step. So as I mentioned, the result metrics, manually it takes around 8 to 10 minutes, but our system takes only 90 seconds. So there is an 85% time reduction. And when we compare this system with the other system, so our system is better in as per the industry trust when we compare the project with the industry. These were just the comparison, and why our project is more better or efficient than our system, it was mentioned. And these were just the references for the project. Thank you, ma'am.
Thank you so much, Soham, for that incredible presentation. Now, I'd like to ask our session chair. Ma'am, do you have any questions for him?
Yeah, so great topic, and I think all the recruiters will be looking forward for this research because it's really interesting, and the way you're saving time, your fellow co-authors and you have done a lot of hard work on this. I wanted to know that how much review of literature you have done for coming on this topic, and how you went through, like how many journals or review of literature you have done for this, and how you'll be implementing this. Already, it is a sponsored research, I guess. So, but
Yes.
future researchers or in future, what can you what can you do for other companies in this regard?
Okay. So to answer the first question, like the review, so we did analyze around 25 to 30 research papers from the conferences as well as journals. So we did took papers from IEEE, Springer, Symposium, and etc. For all those stuff. We did analyze like which methodology should be using to build a system, what AI models or any of the scraping methodology, technology which we could use. And we did found out the useful information, like for embedding, we could use the BERT model. For similarity analysis, we could use any of the large language models. But the main issue we found out that there is no such system available currently in the industry for end-to-end system, like from just dropping the resumes to getting the final shortlisting. So the idea came to our mind that we should build something end-to-end, because earlier the scope was only to build a system where to go get only the shortlisting. But now we then started diving in this and build this end-to-end system. And the next one, as you mentioned, it is as I mentioned, it's a sponsor project, and to integrate it in the industry or the research work. So the future scope can be to include many more platforms. Like there are various competitive platforms like Lead Code, Core Forces, etc., where the candidates solve thousands of questions to go for their interview preparation and get hired into any of the FANG or any of the big companies. So that one, as well as we could integrate many more platforms like Figma, Behance, or the Medium.com articles, where the candidates post about their achievements or their learnings and all those part, and so that it will be a much better system and can be widely used into the industry of HR.
So all the very best along with the other co-authors, and all the very best for your future endeavors. Thank you.
Thank you, ma'am.
Thank you so much, ma'am. Thank you, Soham. Now, I'd like to move forward and call our next author, Navneet Sakuru, to present his paper on robust person authentication using multimodal iris fingerprint biometric fusion with deep feature learning.
Okay.
You may start your presentation.
Yeah. So I'll share the screen.
Yeah.
Can you please give me a minute?
Sure.
So is my screen visible?
Yes, your screen is visible.
One minute. Yeah. Okay. So good morning, everyone. So my project or the paper which I'm going to present now is robust person authentication using a multimodal biometric fusion. And this was our final year major project. So first, let's know what are the problems. So the problems which are generally faced related to security is basically you use certain security items like passwords, pins, and also few systems have unimodal systems where they use certain features. For example, iris or fingerprint or face or any other feature. Now, these systems face certain issues such as spoofing attacks and are either complicated or have low accuracy. So now there is a need for a system which doubles the security and also has a better reliability and higher security. So what can we do in this situation? Here comes our project where we have these objectives. So we are going to combine two features together, and the two features which I chose is fingerprint and iris. Now this improves the authentication, and we have to make sure the FAR and FRR, which is false acceptance rate at false rejection rate, are balanced and also reduced at the same time. And for deep feature learning, we are using CNN, and also Scholal fusion is used, and this ensures a robust system. Now let's get into depth. But before that, let's know like what are the other systems which are already existing. So as you can see, there are these are the papers which we have gone through. Some of the papers which we have gone through, and they are using fingerprint, iris, and some are using unimodal systems. Some are using even multimodal. But the main problem which we noticed was there is high complexity, data set is complex, or accuracy issues. So these were the repetitive problems in all these systems. So we ensured to make a system which is simple to use, basically user friendly. At the same time, the data set is also, very handy. Okay. Now coming to the architecture. So as you can see here, the number one thing is user input. So basically, how does the process work? First, the user accesses the system, then he registers his fingerprint and iris. Now these fingerprint and iris are basically converted into feature vectors. How is it done? Now, the first thing is normalizing these pictures. Obviously, there will be size issues, there will be some lighting issues or some differences. So these problems are normalized using are normalized, are basically normalized, and then CNN is used to extract features. Now, from fingerprint, the features extracted could be certain textures, ridges, and bifurcations, and from iris, it could be some textures such as some circular patterns, etc. Now, these features are converted into something known as feature vectors. Feature vectors are basically simply known to be the numerical representation of these features. That's it. So these features are then stored as templates. So this is one of the process. Now, what if a user is going to access the system, not registering, but accessing the system? So when he tries to access the system, first his finger, same, the process happens, his fingerprint and his iris, that data is converted to feature vectors. Now, this feature vectors of this new user is matched and as compared with the already existing templates. When at the time of registration they have been converted into templates, right, stored templates. So these are compared with those. How is it compared? It is compared using something known as cosine similarity. Now, cosine similarity, it compares the current fingerprint with the already existing or the stored fingerprint templates. For example, if there are 5 people, so there will be 5 templates of 5 fingerprint templates of the same person, of different person, and 5 iris templates of 5 different people. So the current fingerprint is compared with all those existing fingerprints, and the current iris is compared with all those existing iris. So after comparison, the best score of fingerprint and the best score of iris is considered. Now these are taken, and then here comes the score level fusion. After feature matching, score level fusion is done. So score level fusion basically is simply an average of these features. So the best iris score and the best fingerprint score. Based on this, we decide whether the person can be granted access or not. How can we decide that? Using something known as a threshold. So the threshold we implemented is 0.80. So this, after we get a score level fusion, we get a certain score from it, right? That score is compared with this threshold. If it is greater than the threshold, yes, the access is granted. If not, rejected. And to ensure more security, we have also added authentication logs, wherein any user who tries to access the system, the data will be recorded at which time he accessed or which person. So yeah, so this is in depth of what our system actually does. Now coming to the modules, so I've already mentioned a lot about in depth about our system. So I would just maybe go give an overview of all these things. So number one, as I've mentioned, user registration and template storage. It is done in the enrollment module. Now feature extraction, as I've said, it is done using convolutional neural network CNN, and also here match feature vectors. They are converted into feature vectors. Now fusion model, score level fusion is done, which combines these both the scores using an average, and authentication. So basically, we have authentication logs to track the activity of any user who tries to access, or any unauthorized user who tries to access the system. The tools used, the simple tools are used. Front end, we are using Streamlit, back end Python, and for data processing, pre-processing, we are using NumPy and Pandas, and for image processing, OpenCV. So now let's see how does our system look. So as you can see here, this is the main page where you can access the portal. And the moment you access the portal, you'll be coming across this thing where it asks for uploading your fingerprint and your iris. So I've mentioned the process, right? So it goes through that process. And after going through the process, as you can see here, the access is granted. So person one has tried to access the system and he has been granted the access. So that's the security dashboard where you have 4 options. One is a secure portal. So secure portal is basically we try to simulate. It's not actually existing there, but we try to simulate so that it fits into any organization. So it could be hospitals, it could be banks, it could be anything. So secure portal is basically where their confidential data is stored. So also you can delete the user, you can enroll a new user. When you enroll, that is when the templates are created. The permanent templates are created. and authentication logs, as you can see, the fourth one. So let's see in depth. Yeah, here as you can see, there's secure portal. As so, I've given an example of the resources which could be put like data sets, records, and anything. Now enrolling new user. So it is done as in this way, as you can see on the screen, and you can delete the user. And this is the way the authentication logs are registered. So there's timestamp, there's which user has accessed the score of individual feature. Now coming to the advantages, it is definitely has a higher security and also mainly is user friendly. So it's easy to be used by any organization. And coming to the applications, yes, banking for hospitals, maybe to store their confidential records, and other organizations where security is their priority. And coming to the challenges, yes, there could be variations in your fingerprint and iris image quality. So you have to make sure your iris and image quality is uh, has a good quality, and obviously each fingerprint and each iris have different scores. So because of our feature matching using cosine similarity, it makes sure the best score is considered. So yeah, there could be noise and improper image capture. And now coming to the future work. So based on these challenges which we faced, we could implement certain things such as making it more user friendly using a mobile platform, and adding more data set, and also maybe improving the mechanisms. So conclusion. So for a better security, the combination of a cosine similarity and a score level fusion, and considering a multi-model improves the security of any system. So thank you. Hello.
Thank you so much, Navneet.
Yeah. Thank you.
Thank you for such a wonderful presentation and the knowledge that you shared with us today.
Yeah, thank you.
I'd like to ask our session chair if you have any questions for him, ma'am.
Yes, Navneet, the presentation was really nice. You're in depth, thorough with what you have researched. That's a great thing. Till now, the papers that I've seen, everybody has come up with very detailed work, and they're so confident of their work. Some of my one or two questions that I have, Navneet, that what was going in your mind when you come up with this topic, and what was the objective behind working relentlessly on this topic particularly? And how do you see to carry forward this research on ground implementation? Because one thing that I always ask people is that when they're researching something, it should have some implementation. How do they look at it? So these are the two questions that I have for you.
Yes, ma'am. So to be honest, ma'am, this was our major project. So we had to choose a topic then. But when we had chosen the topic, I tried to research like what exactly is happening with the current systems. So yeah, majorly people now, if at all you use certain devices or whatever, unimodal systems are still in working. Like people are using only unimodal systems, either fingerprint or either iris or either only just face. So I thought there could be, I mean, based on the papers also, other papers, I thought, okay, this is a good idea where there's a combination of two features. And now if at all it's face, if it's just face, it's maybe easy to spoof. But if you take in-depth details like an iris or a fingerprint, that would really work out great. If and also their combination could be a really provide a greater security. So that was simply the idea which I had. And also coming to the other features, iris and fingerprint are definitely are something which is complex than just considering a face, but also very I mean it is something where you see in everyday life. If at all you go for an Aadhaar registration, or I mean any work related to Aadhaar or whatever, they'll be asking your iris and fingerprint. So it is everywhere. Now coming to the like how we could so this is one of the questions you have asked. What is the other question, ma'am? Can you please repeat that?
Ground implementation, like further, how will you take this forward, and what are you looking with this research on
Okay.
ground?
Okay. Uh, so the point is this system is completely software based, ma'am. It does not use any scanners, any such things, because the time when we started this, we didn't want it to have. I mean, we wanted to do something which could be done as soon as possible, and also not it doesn't cost us much. So definitely the scanners are very expensive. So we thought, why not create a system which does not require this? So scanner is basically to it's just a gate. It's just a gate to take in the input and just to give it to the system. That's it. So we just try to exclude the scanners for here, and we try to make a system where everything is done within the software. Let it be the pre-processing, let it be any processing, let it be the feature extraction. Everything is done in the system, in the software itself. So if at all you want to take this further, we could give it to certain organizations, and these organizations could also, this is like an additional thing. You could also implement your scanners and everything, your scanners or whatever, like based on your secured environment or based on your ambience. You could you could maybe modify the system by including hardware. So that's it, ma'am. That is the only way we could take it further for other organizations. Yes.
All the very best, Navneet, and I look forward that you have many more accomplishments in your career. So all the best. Thank you.
Thank you so much, ma'am. Thank you, Pranjal.
Thank you, everyone. Now we'll be moving forward. I'd like to invite Rupa to present her paper on urban smart parking management using IoT and React technology. You may start with your presentation.
Hello, good morning. Hello, is
Yes,
it
Rupa, you're audible.
visible?
Yeah, your screen is also visible.
Yeah. My project is Urban Smart Parking Management using IoT and React technology. This is the major project in my final year. One minute. One minute, ma'am. Hello, is it visible?
Yes,
Hello.
Rupa, your screen is visible.
Yeah.
Yes, Rupa,
Objective of the Can I start now?
Yes, you can start.
We developed the web application to the user. They can see the available slots in the parking so that the user can go and park their vehicles. Our main objective is to develop a smart parking management system that help user know the available slots in the parking areas. We use Arduino Uno and ultrasonic sensor to detect parking slots available, and we sending that data to the cloud using ESP8266 Wi-Fi module. And we use React technology to design the web application that displays the available slots in the parking areas. By integrating the hardware and web application, the system enables efficient monitoring for the urban areas. Brief description of the work. As we all know that finding the parking areas in cities is very difficult uh, because of unorganized system and lack of real-time information. We come up with this project, a smart parking platform that connect physical parking spaces with the digital technology using IoT and React technology that help user to find the parking spaces. By combining automation and live data and an interactive design, the users easily use and it is more user friendly so that user can easily use this web application. Prototype components information. Arduino Uno is used to process the data, and ESP8266 is the data that we get, and using ESP8266 Wi-Fi module, we sending the data to the ThinkSpeak cloud, and we use ultrasonic sensor to detect the vehicle slot is empty or not. And in the software, we use React technology to develop the web application, and the ThinkSpeak cloud we use to store the real-time data and display the data. Coming to the methodology of our project, when the vehicle enter into the parking area, ultrasonic sensor detect the parking slot is empty or not. Arduino, collect the data and using ASP8266, sending the data to the ThinkSpeak cloud, and the React technology web application fetching the data from the ThinkSpeak and displaying on the web application. When the user check the web application, if the slot is available, they will go and park their vehicles. If not, they will exit and they will look another area for parking. And coming to the prototype, this is the block diagram, and this is the prototype that we designed. This is the result. When the vehicle enter into the parking area, it is it display in the LED also, and the real time data we sending to the ThinkSpeak and getting that real time data and displaying on the web application, so that user can easily go and see, and if the slot is available, they will go and park their vehicles. And social relevance, the smart parking system reduce road overcrowding and minimize the time, and because the user is spending more time to search for parking areas to park their vehicles. And quick identification of available parking spaces helps save fuel and clean environment. Real-time parking data improves space utilization. Coming to the conclusion and future scope, the smart parking system offers quick and reusable performance, allowing users to find parking more easily. With the integration of IoT and a user-friendly React application, the system is very user-friendly for the user. Coming to the future scope, we can implement the mobile app so that user can more easily access. These are the references of my project. Hello.
Thank you so much, Rupa, for such an insightful presentation. I'd like to ask ma'am if you have any questions for her.
Yeah, Rupa, please throw some. You please tell me the theoretical model or framework when you were considering for doing this research, and how you came to this topic. I know that it was a project, but what made you study this? Because it is a very important research topic that you've taken, and especially for a country like us, it is an effective project. So, and how will you carry this project in forward on the ground? So these are my two questions specifically, especially when people are saying that it has been their project. So I'm really interested to know all these things.
Yes, ma'am. While we started this project, we refer multiple references. In all, I got to know that all are static application. If you want to see the real time data, you should have to reload the page. Then only you can get the real time data, and that is one of the major problem. And second one is that all are looks like a normal web application. In basically this generation, the people use the application or anything that should be very attractive, then only user can use that. Even though it is useful, they will not use if that application is not look good. So I come up with this project. I use the React technology because I no need to reload the page again and again. So it automatically update the data on the web application, and I develop it little more attractive. The user can easily use that. And in future, we can add like a mobile payment if they want to park their vehicle, first they should have to pay amount so that it's very secure that they can come and they park their vehicles. Hello, that's it.
Okay, Rupa. All the very best for your future work. Thank you so much.
Thank you, ma'am.
Thank you, everyone. Next, I'd like to move forward and call upon Jayasri Sangaraju to present her presentation on crop stress detection using ML, if you're here.
Am I audible, ma'am?
Yes, you're audible.
Thank you.
Jayasri, if you're speaking, I'd like to tell you that you're not audible.
Is my screen visible, ma'am?
Yes, your screen is visible.
Okay, thank you. Firstly, my topic is about crop stress detection using ML. And the main abstract is machine learning is used to detect crop stress early. So we used the three models, a random forest, decision tree, and then SVM model. And then introduction. Early crop stress detection will help in improving the crop yield and reduces the losses for farmers. So the study uses AI with random forest model for accurate prediction, and this uses multiple decision trees to predict the final result. And we did the literature survey and we used multiple research papers to get information. And then methodology. Firstly, we'll collect the data set, and we collected the data set from the Kaggle. And then we'll do the data pre-processing. And there are many types of stress in the crops, such as due to excess water or the less water, and due to the pH changes in the soil. And then data pre-processing is done so that the data is further used by the model to detect the type of stress in the crop. And decision tree, SVM, and random forest are used. And out of these three, the random forest is the best one. In the training strategy, it is 80 to 20%, and the overfitting problem is also resolved using this model, random forest. And then out of these three, we chose the random forest model. And then finally, we deployed the application in the render. And we used the ML model using Python. And then the models used are SVM, random forest, and then decision tree. And the results, random forest is having a higher accuracy compared to the remaining two. And we use the heat map. And this is about a website. And the limitations are mainly we chose only wheat, rice, and maize specific to a particular crop. So it can be further improved for it can be further generalized to multiple crops. And then conclusion, random forests successfully detect crop stress with high accuracy. Like future work can be included using IoT integration, deep learning, mobile apps, and then larger data sets. And these are the references. That's
Thank
it.
you, Jayasri, for the wonderful presentation. I'd like to ask our session chair if you have any questions for her.
Hi, Jayashree. The presentation was nice, and just want to know that how much review of literature have you done, particularly for coming on this topic? How many research papers you read, and were there some interesting research papers that you came across while you were doing the study?
Like we studied across nearly 20 research papers. Like we are a team, so we both collectively collected the 20 research papers. And there is one particular paper regarding this topic, and which explains clearly about the random forest implementation in the crop stress detection.
Okay, Jayashree. All the very best for your future work, and all my wishes for you.
Thank you, ma'am.
Thank you. Thank you, Jayashree. Thank you.
Thank you so much, everyone. I'd like to move forward and call our next author, Prem Ghute, to present his paper on Cyber Suraksha app. You may start your presentation. It seems that Prem Ghute is still not there with us. Then I'd like to move forward and conclude our session. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. On behalf of the whole team, thank you for the support during this 11th version and all the 10 previous versions of the conference. We'll be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I also thank our session chair, Dr. Himani Binzola, for chairing this session, and I'd like to present this as a token of appreciation from our team of ICT for SD 2026 and Global Knowledge Research Foundation and partners. I would now like to invite her to kindly deliver a few closing remarks.
Thank you so much, Pranjal. It was
Hello, ma'am. Hello. Hello.
Yes, sir.
Ma'am, Prem Gute group is available. Ma'am, give us 2 minutes.
Okay, sir. Please make hurry. If you could please hurry, we have a time crunch over here. And we've already called you out twice, but there was no response.
Hello, ma'am.
Yes?
I am Anjali here. Please, ma'am, my presentation is remaining. So I request to you.
Ma'am, your presentation is not scheduled in this session. If you could please check again.
Okay.
Hello.
Yes.
Good morning, ma'am. Sorry for late. Actually, my network connection was gone. My name is Prem Gute, ma'am. Can I start the presentation?
Yes, sir. Please start your presentation.
Okay, thank you. Just 1 minute, ma'am. Good morning, ma'am. My name is Prem Gute. I'm from GH Raisoni College. Am I audible? Perfect. Hello.
We could hear
Yes,
you.
sir,
You
you're
please
audible.
Okay, sure. Before I explain my project, I want to tell you one simple example. Imagine there is a one person living in a village. Today, even in village, almost everyone has an Android phones, screen touch phones, and everyone is using banking systems, online systems like that in the form of Google Pay, Phone Pay, and Bharat Pay. So many applications of are available in there. So there are so many cases people is not aware from the cyber fraud. If they receive a message saying your bank account will be blocked, click this link immediately, or the congratulations you are on the 10,000 rupees. So many fake messages, links which are daily comes on the message box on the WhatsApp also there. So this is the real problem we motivated to develop our Cyber Suraksha app. Let me present our project title Cyber Suraksha app. The motivation behind our project is can we means we ask ourselves, can we build an application that tells a normal person, where very normal person, whether something is safe or dangerous before they click it. In actual problems means suppose we go in the villages sites, if we know less people are educated in specifically in villages, they have used the smartphones, Android phones, but they do not have a proper knowledge of about that how to use, and means they have only basic knowledge. So they click the links easily and they get hacked by attackers and everything happens. So we take a problem for an latest example in the Maharashtra government. There is a, scheme is now running KYC like the what we say Ladki Bahin Yojana, which is runs under government of Maharashtra. So in May 2026, there is a KYC. What we say? There is a government gives the sorry actually government says complete the KYC for the Ladki Bahin Yojana. Then the money will receive in every woman's bank account. So what is the process of KYC? There is the official link available on Maharashtra government of Maharashtra portal website. So we have to go it ourselves and complete our KYC itself. But every uh, woman did not know how to complete the KYC. Okay, so in that way they got scams like clicking fake links or everything. So that's why we are make our app. So in the page number, in the problem statement, we see there is a literature survey is also our next page. In we see just 1 minute. We also take some literature surveys also, which are already available, which are similar to like other applications to which is also related to cybersecurity. But our mainly focus is our app provides three uh, three objectives: to check image and to check the OTPs, to check the SMS, to check the links, everything. That type of we are trying to checking with our app. So in the diagram, ma'am, you can see how user use our app. So first, user have our app in mobile. User is there. Suppose he get a phishing link on WhatsApp, like links for suppose example you own a Tata Sierra car for this Diwali or for this Gudi Pada whatever. You have to click the link and fill the information. That's why. So what you can do in that moment, you take the link or copy the link and paste in our app. So when you paste the link in our app, you in our app they perform. It gives you a reply like it's safe, it's suspicious, it's dangerous for you. Then our app you can see the results of the links. It's totally original or totally fake. then you can aware to click or aware to lose something about like the money or important data about yours. So this is the our main objective, and the what we are developing means to check the phishing links and the fake we see the in the screen. Fake means today is the AI world, so many people generate AI images to I, I hope I'm audible properly. So many people checks their means what we say. Some peoples are doing the fake images with AI. Uh, so we have to also check, or we also have to verify it's a real or it's fake. So much confusing for humans. So that's why in our app there is option to image analyzer. You can paste that image also there, then you got everything about the image. It's a fake or it's a AI generated, it's a original, everything. So we use basic not very technical but basic implementation like the with AI. So in next we see the threat detection workflow. User input as was I tell, user input the URL, suppose your analysis, and that analysis can be gone, and you get a result. Next. Uh, here, ma'am, we see the interface of our app actually. How this link detects actually. We zoom on our image. So there is a upload image is the option, and we have to simply upload one image in there, and you get all the guidelines or all the information about image in the below of image. So for image, we use the OCR, is the image only. Actually, we are trying to making a true color for in our app. In hello, ma'am.
Yes, Prem. Thank you so much for your presentation. Ma'am, do you have any
Yeah.
questions for him?
Yeah, I know we are running short of time, Pranjal. Just one question.
Yes. Yes, ma'am,
Prem,
sure.
because Prem, your topic is interesting because cyber security and its concerns are very. Have you done any pilot study on any group that you came across when you were doing this study, or you'll be doing it after this initial study or whatever you've done?
Uh, there is a member which is working in Truecaller. So under their guidance, we make this app. Actually, Truecaller work like before call, you get the notification. It's a spam or it's uh, in various colors like the blue, red, and green color. The notification show you see the notification. So simple way, we have tried to make more implementation in the similar like Truecaller. Before you receive the message on WhatsApp, you see there below it's a safe, suspicious, or a dangerous. You don't need to every time copy the message and paste in our app. You have such a waste of time on these things. So what you have to do, you just open WhatsApp and below you have to see like it's a suspicious. Hope you understand I'm what I'm saying. So that in that way we are trying to implementation fastly, or user get response fastly to understand the messages, images, and the URLs like things. So we are trying to implementation fast, how to make our app fastly, and it's a very easy to use for any user from 10 years child to 60 years our person. Yeah.
Okay. Okay, Prem, thank you so much. All the best for your future endeavors. Thank you.
Yeah, thank you, ma'am. Yeah.
Thank you so much, everyone. Ma'am, if you have any closing remarks for us.
Pranjal, it was a great connecting with the GR Foundations, as I mentioned in the at the intro session also. The session was really great. Kudos to all the paper presenters, because one thing that I've noticed is that everybody who have presented their papers in this technical session, they've really worked on in their domain, and they were very thorough with their presentations. Be it Dr. Viranchi, Lokesh, or Navneet, Sukuru, or Rupa, everybody, means I am not able to take every Venkat, so means everybody was so thorough with their presentation. It was really interesting to know, and uh, looking forward for such sessions, because there was so much learning for there were so many learning points which I have also noted for myself, so that I could also include them in my study. So thank you so much for making me a part of this session, and thank you for the certificate also. And I'm looking forward to be with you in your future research conferences too. So thank you, Pranjal, and thank you so much for anchoring this session so nicely and being so calm and composed during the entire session.
Thank you so much, ma'am, for the compliment. I'd like to extend my sincere gratitude towards you for chairing this session with such a great energy and for your guidance throughout the session and being so active with us.
Thank you so much, Pranjal. Thank you so much.
Yes. Now, I'd like to request everyone to please switch on their camera so we can capture this moment for the virtual conference. Please give me a smile. Thank you so much, everyone, for attending this session. Stay safe, stay healthy. Thank you so much.
So much, Pranjal. Thank you.
Thank you.
Thank you. Thank you all.